Limits. Consider f of x is x squared plus x minus 6 divided by x minus 2. We want to know what happens to this function as x approaches 2. Note that we can't actually make it equal to 2 because of the denominator. We'd be making the denominator 0. You might think substitute 2 in, but we've just mentioned that this is not possible. If we do that, we get f of 2 is 2 squared plus 2 minus 6 over 2 minus 2. And in actual fact, that becomes 0 divided by 0. And 0 divided by 0 is undefined. What we want to be able to do is get close to 2 without actually using 2 itself. So let's use a table of values to do that. So I've got x and I've got f of x. And let's start with 2.1. And if we substitute 2.1 into here and evaluate, we get 5.1. Now let's get closer to 2.01, and that gives me 5.01. 2.001 gives me 5.001. And that pattern seems to continue. We could also try coming from below 2. It appears that the values are heading towards 5. Is there a better way of doing this, however, other than every time we have one of these situations, having a table of values? Well, let's go back and look at the function. And we can factorize the top. Now we've got x minus 2 on the top and x minus 2 on the bottom. Provided x is not equal to 2, we can cancel the x minus 2. Note that you can't do it if x is equal to 2 because it's 0 over 0, which is undefined. But if x is not 2, then x minus 2 is not 0, and therefore they can be cancelled. So, as I've just mentioned, we can't do that if x equals 2, as we can't divide by 0, and also we'd get a 0 on the top. So if we have this, and we exclude the case where x is 2, we can cancel. So we're left with f of x being equal to x plus 3, provided that x is not equal to 2, and we know that it's undefined if x is equal to 2. So we cannot actually use x equals 2, as the function is undefined there. But we can see that if x is a value very close to 2, f of x will be a value very close to 5, because the function is x plus 3, so close to 2 add 3 will be close to 5. We write the limit as x tends to 2 of our function is equal to 5. If we graph this, we find the function looks like this. This is the line y equals x plus 3, but we have a little hole in the middle here at the point where x equals 2, because the function is undefined there. As usual, when we've sketched a function, we should label the graph. And in this case, I would put down the coordinates of the point where it's excluded. So the little hole in the graph, or discontinuity, just here.